The Amulet Research Project is investigating ways to make the prototyping, design, and implementation of advanced user interfaces substantially easier.
The goals of Amulet are to be flexible and open for researchers, easy to learn for students, and robust and fast for developers. Amulet is written in C++ and runs on Unix, Microsoft Windows 95 and Windows NT, and on the Macintosh. Unlike other toolkits and interface builders, Amulet provides high-level facilities to support the entire user interface, not just the widgets like menus and scroll bars. For example, this circuit design program uses Amulet's built-in facilities for selection handles, for creating, moving, and deleting objects, for undoing all operations, for loading and saving the diagrams, etc. As a result, only about 850 lines of code needed to be written for this entire application. Amulet is a layered system. The lowest layer, called Gem, provides operating system and window manager independence so that applications written using Amulet can simply be recompiled and then will run on all platforms. The look and feel can be changed to look like Motif, Windows 95, or the Macintosh. Amulet contains a novel prototype instance object system implemented on top of the C++ object system. In a prototype instance object system, there is no distinction between classes and instances. Any object can serve as a prototype for other objects. Objects are represented as a collection of slots and their values. For example, we can pop up the inspector showing the slots of this rectangle. The slots shown in black are local to this rectangle and change when the object is manipulated. Other slots, like the line style, are shown in blue to indicate that they are inherited. If I set the slot's value, then the object changes, and the slot is now shown in black since it is no longer inherited. If I now set the line style slot in the prototype rectangle, all the other rectangles change since they are still inheriting the prototype's value. Method slots are treated exactly the same as data slots and can be local or inherited in each instance. Amulet's prototype instance object system is an important advantage over other toolkits because it allows the properties of objects to be investigated and manipulated dynamically at runtime. It is simpler to learn and to use than conventional object systems since it unifies the concepts of instances and classes and methods and instance variables. An important feature in Amulet is that any slot of an object can contain a constraint, which calculates the value. Constraints can contain arbitrary C++ code and are re-evaluated whenever the dependent slots change. Constraints are used throughout Amulet. In addition to controlling the positions of objects, constraints are also used to compute the color of buttons depending on whether they are selected or not, and even to compute the size of text objects based on their current content and font. Cycles of constraints are also supported, which makes it easy to keep the application's data consistent with the display. For example, here, the latitude and longitude are updated when the objects are moved on the map, and the objects are updated when the coordinates are edited. Amulet supports multiple coexisting constraint solvers, since researchers like to explore new ways to solve constraints. Amulet includes a one-way formula solver, an experimental multi-way solver, and a new animation constraint system. The animation constraints make it very easy to add animations to an interface. When an animation constraint is attached to a slot and the slot is set with a value, the animation constraints removes the new value, puts the old value back into the slot, and smoothly sets the slot with values interpolated from the old value to the new value. Animations can be set on slots of any type, including the position, the color, and even the vertex list for a polygon. We have defined a number of animations for controlling how objects appear and disappear, including fading out, flying away, shrinking, and exploding. All of these effects are provided in a library and can easily be added to applications. For example, the animations were added to this checkers game with just 5 lines of code. On top of the object and constraint system, the Opal graphics system provides a structured graphics model. When the programmer or user changes a property of the object, Amulet automatically redraws the object and any other objects that are covering it. This makes it much more convenient for programmers since the system automatically determines which objects to redraw. Amulet uses a novel input model where the graphical objects do not handle input events. Instead, a separate set of interactor objects accept all input and manipulate the graphics. We have found that there are only a few kinds of behaviors that are used in direct manipulation interfaces, and Amulet provides these using only a few types of interactors. Each type handles a standard kind of behavior, such as selecting one or more of a set of objects, moving or growing objects with the mouse, or text editing. The interactors are independent of the particular graphics used. So, for example, the same choice interactor can be used for palettes, menus, or even to select objects in a graphics editor. A special feature of Amulet's interactors supports operations across multiple windows, using either a normal graphical object or a window as the feedback. This also supports drag and drop of objects. Amulet supports operations that use gestures, where a single stroke specifies not only the operation to perform, like creating an OR gate, but also where to put it. Using gestures is generally much faster than going back and forth to the palette repeatedly. The gestures themselves are defined using the agate tool by giving about 10 examples of each gesture. The programmer then writes just a few lines of code in the application to associate the gestures with the appropriate actions. When the user selects an operation, Amulet allocates a command object and executes its do method, rather than using callback procedures like in other toolkits. The advantage is that command objects also have slots and methods to support undo, making the commands active or grayed out, and providing help for the command. Amulet provides 3 kinds of built-in undo models. The first is a simple undo model like on the Macintosh. The second is an unlimited undo that allows all operations back to the start to be undone. The third is a novel model that also allows any command in the history to be selected and repeated or undone. Selectively undoing a command causes the inverse of the command to be added to the top of the command history. Commands can also be selectively repeated on new objects. Command objects for standard operations, like selecting, moving, and deleting objects, are supplied in the library and can often be used without change, since there is a standard way to query and modify the graphical objects. Of course, Amulet also contains a full set of widgets, implemented entirely using the lower levels of Amulet. Amulet is in the public domain and is available free of charge by anonymous FTP or through the World Wide Web. Many projects all over the world are using Amulet for a wide variety of applications. In the future, we will be concentrating on providing a set of interactive tools so that most parts of an interface can be created by direct manipulation, as well as adding support for technologies like speech and 3D. The goal is to provide significant productivity gains in user interface development while still providing innovative capabilities to end users.